Date 2024, question 26. Consider a linear homogeneous system of equation AX is equal to 0. So this is my matrix. This is a matrix here, and this is my solution vector, and this is of course a null vector. This is all of course n over n, and this is going to be n times 1, and this is n times 1 solution vector. We have to find out what are the conditions for the non-trivial solution to exist. So very quickly, I will discuss what is a trivial solution and what is a non-trivial. So this is a very short description of the two different types of matrices. Um, Let us take an example. Let's say we have x1 plus 2x2. This is a linear system of equation is equal to 0. This and we have, let's say, another one, 3x1 plus 4x2 is equal to 0. Remember, this is a homogeneous system of equation, linear homogeneous. So this is a linear equation and homogeneous because these are 0. So if I show it in the terms of matrix, so this would be equal to, of course, would be equal to x1, x2, and this, of course, is a solution vector 0. Right? So let us quickly see what will be the solution. If I go from here, this, of course, will have x1 is equal to negative of 2x2, and the second one, of course, is going to be, if I substitute this value in this the second equation, minus 2x2 plus 4x2 is equal to 0. Therefore, we see negative of 2x2 is equal to 0. Therefore, x2 is equal to 0. And therefore, from here, we find that x1 is equal to 0. So, as we can see, both x1 and x2 both are 0. So, this is again is a null vector. That means that's why it's called trivial solution. For if only for values of x1 and x2 is equal to 0 and 0, this particular system of linear homogeneous equation is satisfied. That's why it's called a trivial solution. So basically, if it's like a three-dimensional system, it's only at the origin this system of equations are satisfied. That's why it's called a trivial solution. That means all the values here equal to 0. Okay. Now let us look at the properties of this one. As we can see here, that the determinant of this one is equal to 4 minus 6, that's equal to negative of 2. So determinant is not equal to 0. This is one of the characteristics of trivial solution. And another characteristic of trivial solution is, of course, let's if we look at the rank here, I'm very quickly trying to find out what the rank is. If we put 1, 2, 3, 4 here, let's call this as R1 and R2. In the next step, of course, we can get here 1, 2, and this is going to be equal to, if I put here R1 and if I put R2 minus of 3 R1, as you can see, this is going to be equal to 0, and this is going to be equal to negative of 2, right? So here, of course, the rank is equal to 2. Only if it would have been both of them 0, then of course the rank could have been equal to 1. But here the rank is equal to 2. So as you can see that the order of the matrix is equal to the rank of the matrix. So for a trivial solution, so these are the two very important criteria. As you can see, that's the number one is that the determinant of A is not going to be equal to 0, or the order of matrix is equal to the rank of the matrix. That's a characteristic of trivial. Now let us again quickly see what are the characteristics of a non-trivial solution. So we are looking now at the non-trivial solution. Again, very quickly, let us take an example. Let's take two equations of the type x1 plus 2x2 equal to 0, and another one is 2x1 plus 4x2 is equal to 0. So as you can very immediately see that this equation is just a 2 times multiplier of this equation here. So that way we can have 3 times, 4 times multiplier, etc., etc. So non-trivial solutions exist because these actually represent a line or plane. So there can be like infinite solution points on this lines or plane. So infinite points on this lines or planes, right? So these are called the non-trivial solution. Now let us look at the characteristics of this non-trivial solutions here. First of all, as you can, if I write it in the form of a matrix, this is going to be 1, 2, 2, 4, and of course this is x1, x2, and this is of course equal to 0, 0. Now what is the determinant of this one? Determinant, as you can see, is equal to determinant of A is equal to 4 minus 4, and that of course is equal to 0. Okay. And secondly, let's look at the rank of the matrix. If we do the same operation as I've done for the trivial solution, so from 1 to 4, if we the next operation will be of course equal to 1, 2. If we take so this is going to be 0, 0. How? This is R1 and this would be equal to R2 minus 2 times of R1. So as you can see here, the rank is equal to 1. So the characteristics of the non-trivial solution is number one, that the determinant of the matrix is going to be equal to 0 and the rank is less than the order of the matrix. Here the rank is equal to 1 and the order of the matrix of n is of course equal to 2, right? So let us see, look in the options. So what are the, for the non-trivial solutions to exist, which of the following conditions have to be satisfied? Determinant of A is going to be equal to 0. So that's of course true. Rank is going to be equal to n. No, that is false because that is true only for trivial solution. Okay. Rank less than the order of the matrix. This one here, that is of course true, as we have seen here. And the determinant of A not equal to 0, that's again equal to false. So the correct options are A, correct options are A and C.